All right, welcome. In this video, I'm going to be working some exact equations, examples for differential equations. And these are the ones where, if it's the case that we've got an equation of the form m that might depend on t and y, plus n of t and y multiplied by y prime, that's equal to 0. Okay, this will be exact if my equals nt. Okay, so hopefully for all of these, they're exact, and we'll be able to solve them by, using the same technique that I showed you about just earlier. All right, so I'm going to start with number 1, and I will just copy the problem. Okay, so the first one's 2x plus 3 plus 2y minus 2 multiplied by y prime. That's equaling 0. Okay, so first we're going to check to see, is it exact? Okay, so this is m, and this is n. Okay, the partial derivative of m with respect to y is going to be equal to 0, because there's no y's in that equation. The partial derivative of n with respect to x, well, that's also going to be 0 because this doesn't have any x's in it. Okay, so my is equal to nx means this equation, this differential equation is exact. So I know that my solution has the form f of x and y is equal to some constant, right? It's some level curve of an implicitly, or of a function that takes in 2 variables and gives you back 1. Or you could look at it as an implicitly defined curve. Either way, it's going to be, have x's and y's on the left side, some constant on the right side, and specifically, we'll know that fx equals m, and fy equals n. So I should be able to find f just with some anti-differentiation. So I'll say f on one hand is equal to an antiderivative for 2x plus 3 with respect to x, and it's also equal to an antiderivative for 2y minus 2 with respect to y. Okay, now I know how to anti-differentiate this with respect to x. That would be x squared plus 3x, maybe plus some kind of function that only depended on y. I'll call it g of y. And then it's also equal to, okay, anti-differentiate this, that would be y squared minus 2y plus some other function that only depended on x, maybe. Okay, well, I can see that this other function that depends only on x is going to be x squared plus 3x, and this g of y is going to be y squared minus 2y. So what I can say is that f is going to be equal to x squared plus 3x plus y squared minus 2y. Okay, this one did not come with an initial condition, so my general solution is going to be x squared plus 3x plus y squared minus 2y is equal to some constant. Okay, had they given us an initial condition, I'd have set this up, plugged in on x and y to find the value of c, and then I had a particular solution. All right. Second one, 3t squared minus 2ty plus 2 dt plus 6x squared minus, 6y squared minus t squared plus 3. That down right, 6y squared minus t squared plus 3. All right, dy, that's equal to 0. Okay, so the first thing I'm going to do, I guess I'm going to need a little bit less zoomed in. I'm going to divide everything by dt, and then I'll have 3t squared minus 2ty plus 2 plus 6y squared minus t squared plus 3 dy dt. I'm going to call that y prime is equal to 0. Now I can check to see if it's exact. Okay, is the derivative of this with respect to y? Okay, well, y is going to equal negative 2t. And then nt is going to be, okay, also negative 2t. So this equation is exact, and I'll be able to say, all right, I'm looking for some function my solution is going to be f, which is an antiderivative of 3t squared minus 2ty plus 2 with respect to t, and is also an antiderivative for 6y squared minus t squared plus 3 with respect to y. Okay, we're going to do a little anti-differentiation. This will be t to the 3. On t, that'll be negative t squared, and then plus 2t. And this will also be equal to, okay, with respect to y, I'll add 1 to the power, divide by the new power. Okay, minus t squared, that's a constant with respect to y, so I'll have negative t squared y. Okay, plus 3y. Okay, and then this could maybe have some function of y, and this could have some function of t, and I'm going to see, okay, do I have a function of t over here? Yes. T to the 3 plus 2t. Do I have a function of y? Yes. Okay, so since I'm seeing it over here, I know that there's not anything else that I'm missing, right? So my actual implicit solution is going to be t to the 3rd minus t to the 2y. Okay, well, I already included it there. I don't need to include it twice. Plus 2t plus 2y to the 3 plus 3y. Well, that's going to equal some constant. That's going to be my general solution to number 2. All right. Oh, looks like there's only 2 at the end that, actually require you to go all the way to finding a particular solution, but, I think 2 will be enough. It's just already probably more exact equations than you need to get the point. But, okay, for number 3, I'm going to just copy the problem real quick. X squared y plus 2x y prime. Okay. All right, first I'm going to check, is it exact? Y equals 4xy to the 1st plus 2. And nt, or nx in this case, if y depends on x, then that'll be 4 times x times y to the 1st plus 2. Okay, well, it's the same, so it's exact. I'm going to be able to recover an implicit solution. Okay. So I know my solution is f, which is an antiderivative for 2x y to the 2 plus 2y with respect to x, and is also an antiderivative for 2x squared y plus 2x with respect to y. Okay. Oh, I can see that already this is going to incur a 2xy, and that's also going to incur a 2xy, so that's a good sign. This is going to be, when I anti-differentiate with respect to x, 2x is going to become x squared, and I'll just have a y squared plus 2xy, maybe plus some function that only depends on y, and is also equal to, okay, with respect to y, this is 2x squared y, wait, with respect to y, that's going to be y squared x squared, okay, yeah, wait, that's already what I saw, plus 2xy, plus some other kind of function that would depend on x. Now, suppose h of x was not a constant. Okay, we haven't run into this scenario in a while. I think we ran into this in the 4th unit when we were doing vector analysis, but it's been so long since we were looking for a potential function that I think you may have been like, oh, I don't see any function that only depends on y over here. I don't see any function that only depends on x over here. I'm proposing that there is none besides a constant because, if there was, we would see it over here, and if there was h of x, we'd see it over there. Okay, so if h of x is not just equal to a constant, then the partial of h with respect to x is not equal to 0. Okay, but my hypothesis is f equals x squared y squared plus 2xy. Suppose it had a hanging on h of x. Okay, then that would give me that the partial of f with respect to x was going to be 2xy to the 2 plus 2y plus, whatever dh dx was, which is not 0. But I know that the partial of f with respect to x has to be exactly this, right? That's that's an exact equation. So I know that dH dx has to be 0 for this to be the partial, and so that means if dH dx is 0, then h was in fact at most a constant. Okay, so that's why I'm not going to have an h of x or a g of y, even though I don't see it elsewhere. I don't have to account for the possibility of it, because if it was existing, I'd be seeing it in the partial derivatives up here. So my general solution is going to be x to the 2, y to the 2, plus 2 times x times y is equal to some constant. Okay. Number 4 is e to the t sine of y. Nope, not yet. Oh, this one I might have written too big. E to the t sine y minus 2y sine t plus e to the t cosine y plus 2 cosine t, all multiplied by y prime, and that's going to add together to equal 0. Okay. This one looks a little weird. My is going to be e to the t cosine y minus 2 sine t. And nt is going to be e to the t cosine y minus 2 sine t. It works out. Okay, that's good. It's exact, so I'll be able to say, all right, I'm looking to anti-differentiate e to the t sine y minus 2y sine t with respect to t, and also looking to anti-differentiate e to the t cosine y plus 2 cosine t with respect to y. All right, on t, the antiderivative of e to the t is going to be e to the t. Okay, with respect to t, the antiderivative of negative sine t is going to be positive cosine t. And then it's also going to be, let's see, with respect to y, an antiderivative would be sine of y times e to the t. Okay, we already see that here. Yeah, that's not telling us anything we don't already know. And an antiderivative for 2 cosine t with respect to y would be 2y cosine t. Okay, now, I'm seeing these both together. Okay, that's a good thing. It's going to be f. Okay, and for the same reasons as up above, I'm not going to have any other, hanging on pieces. So my general solution is going to be, no initial condition, it's going to be e to the t sine y plus 2y times cosine of regular t is equal to some constant. Number 5, this one looks like I should be able to solve it in this amount of paper. I have 2x plus y plus 2xy y prime is equal to 0. Okay, so I need to probably, mark my m and my n. Okay, m is going to be 2x plus y squared, and n is going to be 2xy. Okay, so my equals 2y, because the derivative of that is 0, and the derivative of that is 2y. And x is going to be the derivative of 2xy with respect to x, and that will be 2y. Now I'm going to say I'm looking for an antiderivative for 2x plus y squared with respect to x, and also looking for an antiderivative for 2xy with respect to y. Okay. So I'll have x squared plus xy squared, maybe plus something that depends on y. And then 2xy, its antiderivative with respect to y would be x times y to the 2, plus maybe some function that depends only on x. Okay, well that's x squared. G of y is a constant, because if I took the partial derivative of this thing, I would have, with respect to y, I'd have 2xy to the first. That's exactly what I have, so I know that this can be at most a constant, and this, this is going to be, again, at most a constant. And those two constants will get folded together to be the equals c in the general solution. So my general solution is going to be x squared plus xy squared equals some constant. Okay. Now I've got 2 more, and these actually have an initial condition attached to them, so that'll be good for us to find a particular solution, so we know how to do that as well. So over here, number 6 is going to be plus x plus 4y, that's a minus. Alright, so it's x minus 4y multiplied by y prime, that's equal to 0. Alright, so first I'm going to check is my is going to equal 1, and x is also equaling 1. This is exact, it's looking good. Okay, so the thing I'm looking for is an antiderivative of 9x squared plus y minus 1. Dx, and it's also equal to x minus 4y's antiderivative with respect to y. Don't like I copied that wrong, but no, that's it. All right, 9x squared dx, that's going to be 3x to the 3, x times y, and a negative x. It's also going to be, with respect to y, that'll be that xy, okay, that's good, minus 2y squared, okay, that would be the thing dependent on y. I've got some things that depend on x. You can check the partials. This is going to be all of it. Okay, so my general solution is 3x to the 3 minus x plus xy minus 2y squared equals some constant. But now I need to be ready to plug in my initial condition, right, because it said y of 0 equals 1. Okay, so that will give me y equaling 1. Oh, wait, no. X is equal to 0, so that's 0 minus 0 plus 0 minus 2 times y squared is 1 is equal to c. So that means c equals negative 2. And my particular solution is going to be 3x to the 3 minus x plus xy minus 2y squared equals negative 2. It's just that easy. You just plug in to find the value of c, then you plug in on the value of c, and then you've got yourself a particular solution. That's how you do it. All right, now the last one I've got for you is number 7. This is, oh, now this one looks like it's got some excitement. So 2ty, may end up regretting putting this one on the problem set. So divided by t squared plus 1 minus 2t minus, let's just go ahead and I'm going to distribute that minus sign. If you're looking at this on, on the original, I'm going to just distribute the minus sign because that's going to be too much to keep track of. Negative 2 plus the log of t squared plus 1 multiplied by y prime, that adds to 0. All right. Maybe with any luck, I've snipped the wrong problem and this one's not exact. We can just leave it alone and be done. But somehow I doubt that's going to happen. My is going to be 2t over t squared plus 1. And in t, what do you know? That's going to be 2t over t squared plus 1. Okay, so it is exact. Now, finding an antiderivative for this thing, oh, I'm going to find it with respect to y. Okay, I bet we can work with this. And then this thing will be able to use a u substitution. This will be a little challenging, but it's right at y'all's level. It's just what you need. Okay, so I know that the general solution, or the f, is going to be an antiderivative for, okay, y is a constant with respect to t, and I know I'm going to be integrating dt here. So I'm going to actually factor out this y right here so that it's 2t over t squared plus 1. I think that'll make the anti-differentiation quite a bit easier if I just write it like that. Okay. Then antiderivative of negative 2 plus log of t squared plus 1 dy. This antiderivative will actually be really easy because I'll just tack a y onto the negative 2 and then that log. Okay, so when I anti-differentiate this thing, I don't know if you can, I think you would probably see, okay, the derivative of the bottom is the top, so I could use u substitution and let u equal t squared plus 1, and then it's 1 over u du, whatever. You can do that. But you can also say, wait a second, I know how to take the derivative and get this thing. I took the derivative of log of t squared plus 1, and I got 2t over t squared plus 1. So if I'm going the other way, I know that this is going to be y multiplied by the log of t squared plus 1. Okay? And then I'll have a minus t squared, maybe plus some function that depends on y only. And then that will also be equal to negative 2y, that's my function of y only, plus y times the log of t squared plus 1, which I already had over here, so that's a good sign, right? Okay, then I might have some function of t only, and then that's going to be it right here. Okay, so my general solution is going to be y times the log of t squared plus 1 minus t squared minus 2y. That's going to be equal to some constant. And then I was told in the statement of the problem that y of 5 equals 0. Okay, so that's going to tell me that, okay, well, when t is 5, y is 0. Okay, so 0 times that log minus 25 minus 2 zeros is equal to c. So that looks like c is negative 25. And I've got my particular solution ready to go. So that'll be y log of t squared plus 1 minus t squared minus 2y equals negative 25. And before I let you go, I'll just point out that this is the type of implicit equation that we actually can solve for y as a function of t, right? I just grouped everything that had y together. I noticed it was only first power and y, so I could group everything with y together, kind of factor it out and divide away to actually solve for y of t. And so that's my particular solution as well, if you needed an explicit particular solution. If you're cool with an implicit particular solution, which in general we are, then you could just stop there and be happy. But if you needed an explicit formula, then that's how you would do that. That's all I got for you. Thanks for watching.